So when we defining intelligence, so defining artificial intelligence, so it helped to define intelligence first. So if we define intelligence as the ability to achieve complex goals, the word complex is a spectrum. A hammer helps us to achieve a complex goal, and it's not biological. It's artificial. It's a tool. But the things that are happening at the state of the art are what we consider artificial intelligence. And that bar keeps rising. And currently the state of the art in building tools, non-biological tools, artificial tools, to help us achieve complex goals is deep learning. In this course, we'll play with why, and then we'll play with how to start in it, and then we can kind of pontificate about what might happen, what might be on the other side of deep learning. But part of the reason at a high level, right now in artificial intelligence, which we'll talk about that through the lens of computing. From the 50s to about the 80s, computing mostly looked like instruction-based programming. A series of statements, instructions that a computer can follow, with the complexity living in the ifs and thens, or loops. So you can define a strategy based on something you understand, a programmer understands, and then have a computer to help you with it. If we define intelligence as the ability to achieve a complex goal, then learning is the ability to achieve a complex goal, a more complex goal today than you could yesterday. So learning is change in intelligence. And so in machine learning, we got to take the ability to just follow instructions and move it to, our tool, computing, can get better at solving problems over time. So you saw this with spam filters in the 80s and 90s, which made email usable, which were, you'd get an email and we'd label it as spam, and based on the characteristics of another email, a spam filter might recognize it as, oh, this is from the same person. If someone got an email from one address and it was spam, and it got sent to other people, that really broad characteristic of the from line might be an indicator that we shouldn't deliver that to anybody. Deep learning is a subset of machine learning that is differentiated in that we have algorithms that are inspired by the human brain, which allow us to use learning strategies that are inspired by human learning. We know how we learn. So the ability to think about deeply statistical learning versus think about human learning makes us much more powerful, makes the way we can solve problems more intuitive and more kind of to our nature. So because this emulates, because the algorithms here are inspired by the human brain, we're able to really think about the strides that are happening in deep learning often come from reflection on our own knowledge acquisition. It's kind of 2010 and on that we're starting to see this often, and more this year than last year, more last year than the year before. And places that you're seeing deep learning are when you go to Google Assistant or Siri, so these personal assistants that can understand speech and take speech and as an input and output an action. If we think about why that's exciting and important, we've been speaking to each other for millennia. We invented language once, and we invented spelling and the written word, so that's something we have to get used to. Then we invented a keyboard, so we have to translate from the things that we speak about to each other for millennia to this newer technology, which is language, to an even newer technology, which is like typing and mouse. So if we can just speak with our devices, then we can have a much more human interaction. And you see that with when you get 2 or 3-year-olds talking to Alexa or Google Assistant and realizing that some of the barriers they had to connecting to all of our information and making use of computing decrease, which is really exciting. Computer vision is at the backbone of a lot of this stuff, because here the ability to search for a certain picture, when you search dogs in Google Photos, it's going to come up with all pictures of dogs or lakes, all the pictures that are at lakes. And actually they just announced today the Google images will have captions instead of just the classification, which we can talk about the difference between and how and why. You take that same stuff at the consumer level and you put it into computer vision in diagnosing diseases. You can you take an MRI and an expert diagnosis of that MRI, and then you can scale that expertise when that doctor's not there. So by training based on expert classification, you can then scale expertise, which is fascinating as well. And then the ability to take computer vision, natural language processing, and deploy it to machines like self-driving cars, like self-driving tractors, which are using the result of vision to do something. So you're seeing this a lot right now. This course will take on the role of where do we start? Kind of start with language acquisition. This is a table. This is a camera. How do you think about starting the conversation with our machines? If machine learning is the skill set and we're the teachers, how do we teach? Where do we teach? Pressing too many buttons. Those few simple jumping off points, computer vision, natural language processing, and then the control of machines can be applied in a lot of different domains. If you can see who somebody is, then you can let them into your house if they should be there and not if they shouldn't be there. If you can understand images and speech, then all of a sudden we can start to understand everything. We can use what's on YouTube and learn from it. We can read what's on Wikipedia and learn from it and do something. So we're seeing this being used across industries, which is I think why we're so excited about it here. Part of the motivation for this course is to get kind of everybody who thinks about problem solving, not just developers and data scientists, but everyone who thinks about problem solving, to start seeing their problems, or what parts of their problems are AI problems. And to get in and experiment with it and feel what are the tools and what are the limitations of deep learning, we can start to categorize, wait, this feels like a deep learning problem. I have really great input-output data and lots of it. Let me just try it. And if it's not, maybe part of it is. So hopefully today your brain gets spinning a little bit on what you can solve. This is the last whoa, yeah, it's so cool slide, and then we'll get into the concrete. You've probably heard a lot of the hype around, or the claims that can be thought, that can feel like hype. AI is the fourth industrial revolution. It's the new electricity. In this case, we've claimed it's the fourth revolution in knowledge acquisition. This one feels really rooted, and kind of explain why I'm excited about it through this lens. Life has been, so if we talk about artificial intelligence, we talk about just intelligence, life has been gaining intelligence in a lot of different ways over a very long time. And if again we define intelligence as the ability to achieve a complex goal, if I'm a plant, a complex goal might be surviving with less sunlight. So over generations, my leaves might get bigger. So I'm learning over generations to achieve more complex goals today than I could yesterday. At this time scale, we were talking about over multiple generations, until this stumbled upon the brain. And the brain could all of a sudden learn within one generation, within one lifetime, from experience. You have a child being born today who has the same hardware as a child being born in 1,500 years ago. A kid 1,500 years ago might use that hardware to become a blacksmith, and today they might use that hardware to become a deep learning practitioner. So based on experience. The technology of culture, the written word, so language, which we're exchanging right now, the book, allows us to say, I've discovered some things, let me share those with everybody else, and then my knowledge combined with your knowledge, my knowledge gets larger, and we as a society know more. So this is a step function in knowledge acquisition. This is fascinating because even when you talk about through Wikipedia, it's still in this lens. It's fascinating and it's world-changing. But the difference when you come to machine intelligence is the ability to take the result of this and not just share it with each other, but to, for us to infer, for us to take this idea and connect them to form new ideas. Our machines can take this idea and connect them to form new ideas, which really allows us to solve problems we've never solved before. Currently, it's very, like all of the machine intelligence is very narrow. We're talking about vision. But if I teach a machine to identify a dog, it's not so far for it to learn to identify a horse. So the ability to take what it's learned and build on top of it and create new ideas and new solutions to problems. Let's come to the real world, to the concrete a little bit, so what's the difference? Like, what is the difference as a practitioner? If the skill set of the last couple decades was programming, and it might claim that the skill set of the next is involving deep learning and AI, what mindset should I be adopting? The real key is the difference between a practitioner designing features, us recognizing here are the things that make driving successful or unsuccessful. Hands at 10 and 2, looking around everywhere, stopping at stop signs, and by the way, a stop sign is that octagon thing with these it's an octagon. It's red with a white border, and we're describing these features based on how we do it. And then putting that to a model, maybe it's a statistical model or something different, and fitting between our features and an output. To an end-to-end, let me identify what is the input that I care about, what's the output that I want to associate it with, and letting a neural network, which I promise we'll define deeply throughout the day, learn the map between the two. This end-to-end format means basically we're making use of patterns we recognize. So, for example, you might have seen figures that look like this when we're talking, like with relation to deep learning, where you have input nodes, output nodes, and some neurons in the middle, and they're connected. We're going to play, like I said, deeply in here today. But I want to start just by talking about inputs and outputs and call this just the map between the two. Let's take a self-driving car as an example. The outputs of a self-driving car are pretty simple. You have steering angle, brake pressure, and accelerator pressure. That's it. So 3 outputs. So you have these 3 outputs. Inputs to a self-driving car are more complex. It's all of the sensor data around it. But we can, whatever these 5 things represent, maybe there would be hundreds of thousands. Doesn't really matter. If we have lots of driving data from a lot of people, millions of miles on the road, and what the sensor data sensed and what the driver action was, instead of describing steps between this person saw a red light, so they stopped. Here are the raw pixels from the world they were driving in, and sounds, and whatever else feels important. And here's what they did. Millions and millions of miles of that training and the right architecture, this map becomes effective to go out and take this and put it into your car, or my car, or someone else's car, or all the cars. And then we start to see, well, this driver, like, we can score the driver even and say, like, people don't like that ride. Let's not care so much about this driver that was reckless. Let's instead focus on this driver who's had X number of safe miles in their history. So that's where you get into the superhuman level, is when we start talking about we can filter. We don't just have to do it exactly as well as we do. We can instead do it as well as the best of us do. And then maybe identify the characteristics that we consider best, and that's how we can start to iterate and get better. But at its core, so we got kind of into that self-driving car example, is that we're really focused on end to end. What's the input? What's the output? Find a lot of examples and trust our machines to learn.